Most of our conversation surrounding fractions so far has been around types of fractions, how to manipulate them, little properties of fractions, how to simplify them. Well, now we need to start doing operations with fractions. And so we're going to start with multiplication. So I'm going to give you another, I'm going to call it an algebraic definition. And so here's what multiplication of fractions looks like. You have two fractions. We'll say the first one is a over b. Two different numbers, one on top, one on bottom. Doesn't matter which one's bigger. It just matters that their b is not 0, right? That's sort of the important thing. A over b times c over d. So another fraction where we have two other numbers, c and d. So when we multiply with fractions, we multiply the numerators and we multiply the denominators. And so what we would get is AC, right? A times C over B times D. AC over BD. And that's our product, right? The result from multiplication. Now, this is, again, an algebraic definition for how to multiply with fractions. Let's not think about that necessarily. Let's get down to what actually happens when I start doing them. And so I'm going to start with this problem. 2/3 times 9/10. So I'm going to, kind of like I've done before, I'm going to approach this problem two ways. I'm going to approach it the way you've probably always done it, and then I'm going to approach it from a new way that I think is going to benefit you more as you move forward. It's so good to have multiple ways to think about things. So the first way, 2/3 times 9/10. The first way you've probably done before is you just, like we just said, you multiply the numerators, you multiply the denominators. This gives you 18 over 30, right? 18 over 30. But then you must simplify it. You have to simplify, reduce it. So now you come into this process of saying, okay, I've got to divide by something, or even better, think back to our prime factorizations. Remember how we prime factorized, is a good word, and canceled? So 18 can be written as 2 times 3 times 3. Think about a factor tree. You can pause the video, do this yourself. And 30 is 2 times 3 times 5. So again, you multiply and then simplify. 2's would cancel. 3's would cancel. And all you're left with is 3 over 5. So we can say that this would come out to 3/5. Okay? So that's one way to approach it. First multiply, then simplify. I like this approach better. First simplify, then multiply. Oh, we can do it in kind of the opposite order. Yeah. So here's what this might look like. 2/3 times 9/10. Start off by looking for things you can cancel. Now, you might be able to just look at these and figure out what can cancel, or you can approach it using prime factorizations. The fraction 2/3 uses two prime numbers, so I can't do anything with 2 or 3. But I can factor the 9 into 3 times 3, and I can factor the 10 into 2 times 5. So look what happens here. We took 2/3, and I just rewrote it, right? Here. I took 9/10, and I rewrote it here. Okay? It's the same numbers, right? We just factored it. If you remember our conversation about canceling and simplifying fractions, we said remove common factors. Well, all that's going to happen is all this stuff across the top is just going to get multiplied together into one big fraction, 2 times 3 times 3, and then the same thing on the bottom, 3 times 2 times 5. And now we can cancel the common factors. It doesn't matter that the 2's aren't right on top of each other, right? It doesn't matter that this 2 and this 2 came from different numbers, right? The 2 and the 10. We can still cancel them. We could have even done it right here. The same thing with the 3 and the 3. This 3 and this 3 are common factors. It doesn't matter that they were diagonal from each other. They can still cancel. And guess what? We still end up with the same numbers on top and bottom, 3/5. In fact, think about what we did differently in this problem compared to this one. First, we multiplied here to get bigger numbers, and then we took those big numbers and we factored them into these prime factorizations. Here, we didn't bother multiplying them first. We just factored them immediately. This actually saves us a step. I got to this prime factorization a step earlier than from the first method. So when you're multiplying, it can be really beneficial to start by factoring your numbers. So let's try it in a different one. Let's say we have a whole number, 4 times 7/8. 4 times 7/8. Well, here's a situation where you're given a whole number. If you remember to our conversation around properties, any whole number also means that whole number over 1. 4 and 4 over 1 are the same thing. And sometimes it can be helpful to see things all as a fraction when you're working with fractions. So let's take our new approach. Let's factor everything. 4 is 2 times 2 over 1. Here's our times. I'm going to rewrite it here. Times 7 is 7. And 8 is, if I factor it, 2 times 2 times 2. So let's take a look. We can imagine these actually just as one big fraction where the tops and the bottoms are multiplied, right? Everything across the top, everything across the bottom. Now we cancel a 2 with the 2, another 2 with another 2. What do we have left? 7 on top, 1 times 2 on the bottom. 7/2. That's an improper fraction. It's okay. I like it. Right? So if you have a whole number, you can put it over 1 and then multiply everything straight across. Let's look at one more. Let's look at 6/10 times 1 2/3. So I wanted to show you something where we had a mixed number, right? Remember this thing, a mixed number? We can't really do this multiplication until this thing looks like a fraction, right? This kind of gives us a huh. You can't multiply numerators and denominators if we have this whole number sort of sitting out there. So we can use our method of converting it. 3 times 1 is 3, plus 2 is 5. So we can rewrite this thing as 5/3. 3 times 1 plus 2. Rewriting it as an improper fraction allows us to then factor and multiply. So now that we've got that taken care of, let's do our factorization. 6 is 2 times 3. 10 is 2 times 5. Times, I've done this, I've got my times. And then 5 is a prime number, and 3 is a prime number. So that's all I can do. These and these are fine the way they are. Now we can cancel, remove common factors. 2 over 2. 3 and 3, all right. And 5 and 5. Uh-oh. What happened? Everything canceled out. So pause and think, what does this mean? Well, what happens when things really are canceled? What happens when you have any number over itself, like 5 over 5? 5 over 5 is equal to 1. Something divided by itself is 1. When you cancel, what you're really doing is changing it to 1. So if everything cancels from a numerator or everything cancels from a denominator, there's still a 1 that's just sort of hanging out there. It's invisible, but it's there. It's that multiplicative identity. Anything times 1 is just itself. So what happens when we have 1 over 1? It equals 1. Okay? So the key thing there is, if everything cancels from a numerator, there's still a times 1. Same thing, if everything cancels from a denominator, there's still a times 1. Now I just want to finish off with a multiplication problem that might show up in words. What is 2/3 of 75? Pause the video, see if you can answer that question. Then, once you think you have an answer, see if you can go back and try a different way of solving it. There are lots of different ways of thinking about this. And so I always like pictures when I'm trying to solve a problem. And so one thing I might do is I might say, okay, I've got a circle, I've got a thing, and that thing represents the number 75, right? Because I'm going to be doing a fraction of it. And I know I'm taking 2/3 of it, so I'm going to split it up into 3 sections, 3 equal sections, right? Here's 2 of those 3 things shaded in. Now, I'm like, okay, if my whole thing represents the number 75, and they have to be 3 equal sections, how many would be in each section? Well, 75, if I divide it into 3 equal sections, equals 25. Which means that there would be 25 here, 25 here, and 25 there. So 2/3 of 25 would be 25 and 25, which is 50. And the other 25 is not included. So that's a nice way to visualize what's happening. Now, you can't do every problem like that because sometimes they just don't turn out nicely. What you might notice, though, is this word of, whenever you're taking a fraction or a decimal or percentage of some other number, a mathematical operation would be multiply it. 2/3 times 75. In an earlier problem, we put that whole number over 1, right? Watch what happens here. Pay close attention to what happens with the numbers as we factor it. Think of the picture of what we just drew. We have 2, and we have 3, times 25 can be factored in, or 75 can be factored into 3 times 5 times 5, right? 3 times 5 times 5. And 1 is just 1. So this is factored, that's all we can do. And the only thing that cancels here is the 3. So look what happens now. What we really did was we divided this 3 out of the top and the bottom, right? And so the thing that's left on top is 25, right? 5 times 5 times 2. The same thing that we had here. We end up with 2 times 5 times 5. And then, remember, divided by 1? 2 times 5 times 5 is 50. Divided by 1 is itself, is 50. So here's more of a procedural approach. When you are doing a fraction or percentage or decimal of something, you're going to be multiplying.